Hi, it's Alan Begg here. Today I'm going to continue on with my presentations on three-dimensional objects. This is going to be part 2 and it's going to be volume formulae. Here's a reminder of some 3D objects: a cylinder, cone, cube, sphere, pyramid and prism. This is the formula for the volume of a cube. A cubed. A times A times A cubed. A times A times A. This is the formula for a cuboid or a rectangular prism. Length times width times height. Length times width times height. L times W times H. This is the volume formula for a triangular prism. The volume equals the area of the triangle cross-section times the length. Area of triangular cross-section times the length. In which case, because it's a triangle, the area of a triangle is half of the width times the height. So the volume is half of the width times the height times the length. The volume for a triangular prism is half the width times the height times the length. Width, height, length. This is the volume for a trapezoidal prism. Half of B1 plus B2 times H times L. Half of B1 plus B2 times H for height times L for length. The volume of a trapezoidal prism is half times B1 plus B2 times H times L. This is the volume for a pyramid, a square-based pyramid. Volume equals 1/3 of the area of the square base times height. Volume equals 1/3 of the area of the square base times height. So the area of the square base is A squared. The volume of the square-based pyramid is 1/3 times A squared times H. 1/3 of A squared, which is the area of the square base, times H for height. This is the volume for a triangular-based pyramid. 1/3 of the area of the triangle base times height. So the area of the triangle base is a half of length times width. So the volume for a triangular-based pyramid is 1/3 times half times length times width times height. The volume for a triangular-based pyramid is 1/3 times half times L times W times H. BODMAS applies. This is the volume for a cylinder or a circular prism. Volume equals pi r squared h. This is the volume formula for a cone or a circular pyramid. volume equals 1/3 times pi r squared h. This is the volume formula for a sphere. Volume equals 4/3 times pi r cubed. Now, an alternative way of quoting the formula for the volume of a sphere could be 4/3 times pi r squared h. Now, you'll have seen on the last three slides for the cone, the cylinder and the sphere, there's a common feature in the volume formula for these three 3D objects, and that is pi r squared h. Each of the formulas for volume for cone, cylinder and sphere contain pi r squared h. Volume of a cylinder, pi r squared h. Volume of a cone, 1/3 pi r squared h. Volume of a sphere, 4/3 pi r squared h. The common feature for each of these 3D objects is a circle. And each of the three volume formulae have this feature, pi r squared h. So if that's the case, why do we quote the volume formula for a sphere as 4/3 pi r cubed and not 4/3 pi r squared h? So the reason for that is the distance to the edge of a circle from the center of a circle, otherwise known as the radius, is the same all the way around. So it doesn't matter which direction you go from the center of the circle to the edge of the circle, they're all the same size. It's all the same radius size. So if we look at this for a sphere, h is the same as r for all spheres. So the height is the same as the radius for all spheres. So if we look at the alternative way of quoting the volume formula, 4/3 times pi r squared h, and remember that height equals radius for all spheres, so h equals r for all squares. So substitute the h for an r, you get 4/3 pi r squared times another r. To simplify that, you would have 4/3 times pi r cubed. So that's why a sphere formula is quoted as 4/3 times pi r cubed and not 4/3 times pi r squared h, because h and r are the exact same for all spheres. Thanks for listening, and as always, any queries, questions or inquiries in the comments section. Thanks again.